Hello, good afternoon, everyone. I think we are still missing few people in the room, but in the interest of time, I would start. So at the outset, I would like to thank Tono and Jeremy for giving us an opportunity and invite here to present the topics which are quite active in the RATS community and connect with the ecosystem. I hope this connects with the audience here. So basically, I'm going to talk about remote attestation with multiple verifiers. This topic started back in ITF 123 in Madrid in Spain when we were discussing what are the challenges today with remote attestation. And very soon we realized a very common problem which we are facing is how do we attest when there are multiple components. So I'm going to start my presentation with the main challenges which we face in the remote attestation today. So basically, why complexity in remote attestation? What is there which is kind of the problem area? So as the time has progressed, technologies have made a tremendous amount of advancement, and so the devices have become complex now. Effectively now, what we term as a tester in RAT's terminology, endpoint, device, whatever you may want to call it, is more like a composite, is a collection of attesters because you have multiple components within an attester. Thus, it becomes a composite attester situation. And then every individual component has its own remote attestation story. It has its own root of trust. It has its own evidence. So effectively, this becomes a composition story, compositional attestation, meaning to assess the trustworthiness of the entire composition, which one needs to make the trust decision. To trust the composition, one need to trust every single component. And thus, single component trustworthiness combined together gives the overall trustworthiness of the entire composite attester. So just take an example here. In the real world case, I'm just taking one simple example though. It's a confidential computing with model training use case where you have a CPU, which is effectively controlling the training aspect, but the most of the bulk of the work is done by the GPU. So this is each system in this system there is a CPU which has its own root of trust, the GPU which has its own root of trust, and effectively the trustworthiness is assessed when you assess the trustworthiness of this compound entity. And within the CPU itself, you would see that a workload is running in a confidential computing environment, which is doing the job, and workload runs on a hardware platform. And both are coming from different parts of supply chain. The workload is deployed by a workload owner, where the hardware vendor, which is providing the hardware platform for the workload to run, is coming from a different supply chain. So itself, within the CPU itself, there is a layers, and this is what we call layered attester in terms of RAT's terminology. So here is the example of a complex attester within a CPU itself, where there is a workload which is running on a hardware platform, and that's the trust boundary shown in there. And this is effectively been documented in the RATS ecosystem by layered attester, where the attesting environment is collecting claims about the root, and then the target environment for which the claims are being measured itself is an attesting environment for the layer above it. And thus, the layered attestation evidence is echoed to the verifier. So this is even like scaling up when you have multiple component attesters like attester B and C producing its own evidence, and so is attester A. Then somebody needs to join that together to send it to an verifier, and that's where the lead attester is a kind of a role which is being played here by attester A. The job of a lead attester is to kind of combine the evidence, maybe put an outer signature so that the entire packet is security protected in there. So this is kind of one type of attester composition layout. There is, of course, many similar There are various topologies. We will talk about that in a bit later. But this is showing a high-level view of what could a composition look like in terms of producing the attestation evidence. So when the attesters become composite, when there are multiple evidences packed within an evidence, what does it impact in terms of verification? As you can see now, different components come from different vendors. And when different components join together, it means we need different type of verifiers to assess the trustworthiness. Why? One may ask why. Because the different components may have different intricacies of verification. They are different root of trust, which means their policies for verification may be different. And therefore, there is a need for multiple verifiers because there may not a single, and if let's assume that a single entity may decide to stand up and do all the verification, it may not have the required knowledge to do the complete appraisal of the entire composition. It may be because it may feel that that's too complicated, or there is a deployment concern. Why would one entity want to spend time and effort if that verification is already provided by that component vendor? It may just want to interface with that. So there could be many reasons why one may not want to kind of make it everything in a single unified verifier. So there are needs of multiple verifiers does actually come into picture. And once you have that kind of a need, then one needs to decide how they talk to each other, what would be the protocols. And so we decided that let's target this problem. Let's try to see how multiple verifiers need to coordinate to do the verification of appraisal to the appraisal. So we started first with a hierarchical model. This is a quite simple, actually, this model in which says that the attester is basically the one who generates the compound evidence or composite evidence. In the background check model of the rats, it could be the relying party also can send the evidence. So that's why there is an attester or relying party on the left blue box. Is sending a composite evidence. The lead verifier is the one. Lead verifier is the one which who understands the overall topology of the composite attester. So it would break down the composition into individual pieces of evidence, and then it may do some kind of a signature verification if or there is an outer signature, or there may be possibility that there may not be an outer signature, but these individual evidences are cryptographically linked to each other. So there could be various ways of packing the compound evidence. But as soon as the lead verifier breaks down it into individual evidence, it then relays those evidence to individual verifiers, and it's wait for the attestation results coming from these verifiers. If the individual evidences are not integrity protected, then it may be the requirement for a lead verifier to sign these individual evidences and send it to their individual component verifiers. And then once the attestation results are relayed back from the individual verifiers, then it needs to, attestation result needs to be combined and signed by the lead verifier to what we call here as an aggregated attestation results to the relying party or attester. Here, it is important to say that the lead verifier may add its own claims, what we call as verifier added claims to this, what policy has been applied, or as some extra evidence related to composition may be echoed back to the attester. So this is the one topology. The other topology could be a cascade model where the component evidence is received by any single verifier in the chain. It does the it decodes the composite evidence, just does the partial appraisal of only part of the evidence, creates an attestation results called partial attestation results, and pass on the composite evidence to the subsequent verifier, which does part of the appraisal for whatever evidence it understands. And the chain continues until the complete appraisal is finished, and the aggregated attestation result is echoed back to the attester or relying party, just reversing the chain. So just a simple chaining model as against to the controller model, which is called the hierarchical model. And then potentially there could be a combination of these two models where there could be a part chaining followed by part hierarchical topology, where the verifier 2 acts as a lead verifier and breaks down the evidence and passes on to verifier 3, 4, 5 and gets the result back. Okay, so I'm just going to give you a brief update on when we started this dealing compositions within the RATS terminology, what standards we have been working on in IETF. So there is a effort going on on the attester side called taxonomy of composite attesters. The idea of this draft is to explain what type of composition exists. This draft is not yet adopted, and anybody who is here or on the call may want to review the draft and provide their comments, or if you think that we have omitted something or we haven't taken care of, you're welcome to make the comments, and feel free to join the design meetings which we are if you subscribe to the RATS channel, you will come to know about the design meetings which happens every alternate week. Then, as I explained those topologies in my slide deck, there is a remote attestation with multi-verifiers is a ongoing activity. The draft is yet to be adopted, and the work is progressing quite enthusiastically on this. And then there's a concise selector of endorsement and reference values, which is already adopted as part of the ITF RATS. And equivalent to the standards work, we have open source implementation in Project Verizon, which is a confidential computing backed open source project, which deals with all the stuff. We are kind of we are making sure that whatever standards we develop, as from the left hand side, the equivalent support arrives in the open source implementation. So my colleague will present in more detail about the Verizon architecture and what exactly it is capable of doing in terms not only about the composition, but in general about attestation. So I'm just give you a brief highlight of what are the repositories which and what they do about. So composite attester can be constructed using RATS concise message wrapper. And there's a RATS-D called RATS-Daemon, how you can pull attestation evidence from multiple root of trust and combine them and ship them to a verifier. That is the repository about composite attesters. Then followed by the multi-verifier. We haven't actually started the work, but the work is very much in the pipeline, and we are going to start work on implementing the lead verifier of the hierarchical pattern, which I just explained you. Followed, and there is already good deal of work already done on concise selector for endorsement and reference values. And how do we combine the attestation results from each of the component verifiers to make the aggregated attestation results? We kind of looked at this aspect, and the existing repositories in Verizon can very well handle that. The EAR in that link stands for EAT attestation results, and we have Golang, Rust, and Python implementation of EAT attestation results already available in the library. Yeah, that's all. Thank you, everyone. Any questions? Happy to answer.
Yeah, I do have question. Can I start?
Yeah, please, Usama, go ahead.
Yeah, thanks, Yogesh. It was interesting, as I have raised many times in the RATS meeting as well. So I'm just relaying my concerns back over to you. So
Yeah.
the problem that multi-verifiers has, that it not only increases the security risks in the sense that you increase your TCP, right? So this is increasing the security risks compared to the integrated verifier. And it also increases your privacy risks, because now instead of only sending it to one verifier, you are sending your potentially sensitive information, which could be like even identifying a person or something like that, and over to multiple verifiers, which increases your privacy risks. And other than that, so the argument that you presented that, okay, so there are multiple attesters and you need to do that, and you showed that there is a need for that. I completely disagree with that. So there is not a need for that. One verifier can actually verify that if all the policies were integrated into that specific verifier.
Okay, one thing is a theoretical aspect of this, what you're trying to say. Okay, there are two aspects you said. Let me talk about the security and privacy concerns. Yes, multi-verifier increases the trusted computing base. No, that's definitely clear. But there are ways to mitigate the security concerns which you have said. And I think what we have, I think you must have read the level of degree of detailed security analysis we have done, how to mitigate the kind of things. If a single verifier is getting revealed the evidence, then equivalently the same evidence goes passed through multi-verifiers. So if one verifier knows about the evidence, and if there is a way to solve that problem, the same applies of how do you mitigate the privacy concerns of passing from one verifier to multi-verifiers. That doesn't simply, uh, that argument doesn't stand up really.
No, 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 it's not equivalent. You can't say that equivalent. So for example, I trust you and I pass some information to you is quite
Correct.
different from sending it over to all the people which are in this Zoom call, right? So individual sending and trusting you is different from trusting all the global platform, or let's say like the 50 attendees who are attending or listening to this call. That's, I completely disagree that that's not equivalent. The word equivalent is completely illogical here.
Okay, the verifier group is trustworthy ecosystem. And then further, there are ways to protect that evidence going from one verifier to another. You can have a mechanism where the individual verifier encrypt the evidence and send it to the other verifier. And that kind of mechanism can be done if there is a specific security concern like that. And I think that solution or the kind of proposal is already there in the draft. So I'm not worried about that aspect. Yeah.
So I'll add one short comment to that and then pass on to Sampo. Even disregarding whether there are theoretical minor disadvantages, the realities of markets and the operation of companies are such that realistically single attesters will not work. A sizable company is not going to outsource the problem of verifying whether its device is trustworthy to somebody else who may well be a competitor. It's simply a commercially unrealistic position. And in some cases, we rely on regulation and contractual agreements as mechanisms to provide assurances which might be theoretically provided by security, but are practically not realistically provided that way. So as an example, I am probably more scared of Qualcomm's lawyers than I am of having a theoretically non-optimal implementation of security. So there are commercial aspects to this that simply mean that alternate approaches probably do not scale. So I'll pass to Sampo and then back to Osama, but we again have to go fairly quickly. So Sampo.
Yes, hi Yogesh. So have you considered the possibility that lead attester won't just forward the whole evidence or entire token to the sub verifiers, but it would construct some sort of like a subset token, which it would sign by itself
Yeah,
and send that.
exactly. So um, if as I mentioned in my presentation, if the individual evidence is not integrity protected, then lead verifier may add its own signature to the individual evidence 1 and 2, so that it is protected. So it can take the security the way the trust model demands. So as I mentioned, even if there is a concern of sharing that privacy information, lead verifier may decide to encrypt the evidence. So it's really the kind of trust model you are comfortable in deploying in your use case.
Yes, and it could even not send. It could even. I was thinking that it could even construct some sort of derived token, uh, which wouldn't have certain claims at all.
Absolutely, yes.
Yeah.
That's a very good point, which you said. It could block certain PII information and use some kind of a DAA mechanism to protect the evidence. That's
Yeah.
totally a valid solution there as well. Yeah.
Yeah, very quickly following up on the comment that was made. So first, I would say that policies are not supposed to be private, right? So if they are supposed to be public, I would at least argue that, and that's not an argument for saying that okay, so the policies are not available and we are not releasing our policy because of the intellectual property and blah blah blah. The point is that it breaks the open source ecosystem that we are trying to develop at RATS. But one could have its own position. I, of course, don't buy that argument. Yeah, that's, of course, my position on that.
Okay, I mean, policy is something which very much specific to a particular deployment as well, right? On a particular deployment, I may have a different policy than another deployment. So I don't want to rat hole on this policy subject, but I have strong opinions to say that not everything in particular is something which a particular vendor may want to reveal. So yeah.
So I'll pass quickly to Henk, and then we need to move on.
Yeah,
Yes,
I'm sorry for adding this. So this is cleanup duty. We must clean this up. It is implemented today. Like in data centers, you have the H100 where you nest NVIDIA evidence and the Intel evidence. It's limited to data centers, this problem mostly, but you see it everywhere. So multi-verifier things are a thing, and there's simply no standardization for it today. So you can't make it worse. You only can make it better, actually.
Yeah, I fully agree. Thanks, Henk.
Okay, so I think we need to move on.